All right, today we're going to completely flip the script on how we think about menopause. We're going beyond the usual talk about hormones to uncover what's really triggering one of its most common symptoms. Let's dive into the brain switch.
So let's get real for a second. Have you ever wondered what's actually going on inside your body during a hot flash? I mean, we all know that sudden, intense wave of heat, but for a long time, the science behind it has been surprisingly fuzzy. What is the actual trigger?
Well, it turns out the answer isn't just about hormones. The real culprit is a neurological misfire, basically a false alarm going off deep inside the brain. And you know what? This discovery completely reframes the entire experience.
Okay, so to really get how this works, we've got to put on our detective hats. We're heading deep into the brain's command center, a tiny but incredibly powerful region that's running the whole show.
And this is where we meet the main characters of our story, the KNDy neurons. I know, it's a funny name. These are a tiny cluster of brain cells located in the hypothalamus, and you can think of them as the master switch for the entire reproductive system.
So what's with the name KNDy? Well, it actually stands for the chemicals these neurons pump out. It's easiest to think of it like an accelerator and a brake. They release neurokinin B, which is basically the go signal, and then they release dynorphin, which is the stop signal. It's a beautifully balanced system, all designed to keep things running just right. And that balance, that push and pull, is absolutely crucial. See, in their normal, day-to-day job, these KNDy neurons act like a finely tuned pacemaker. They send out these rhythmic pulses that control the release of essential reproductive hormones, keeping the entire system on a nice, predictable schedule. But what happens when that perfectly predictable schedule just gets thrown into total chaos? Let's talk about the trigger, that moment when this finely tuned switch gets flipped.
So what's the one thing that keeps this whole powerful go and stop system from just spinning out of control? Well, it's one thing: estrogen. Estrogen is the great regulator here. It provides what scientists call negative feedback, which is basically its way of telling these very energetic neurons, hey, cool it, calm down, everything's fine.
And this is the critical moment. During menopause, estrogen levels just plummet. And when that happens, that calming, hey, cool it signal, it's gone. Without that break, the KNDy neurons just, well, they go nuts. They become hyperactive, and they even start to grow larger from all that frantic activity.
All right, so this hyperactive state leads us right to the climax of our story. This is the moment. The brain sounds a false alarm that has some very real, very physical consequences. Let's just walk through this chain reaction step by step. First, estrogen drops. Second, the KNDy neurons lose their chill-out signal. Third, they go into overdrive, flooding the system with that go signal, neurokinin B. This misfire sends a totally false overheat signal to the brain's thermostat. And finally, the body panics and hits the emergency cool-down button. And that thermostat, it's not just a cute metaphor, it's a real place in your brain called the preoptic area. And that cool-down response it triggers, yeah, that's exactly what a hot flash feels like. The body desperately tries to shed heat it doesn't have by opening up blood vessels, that's the flushing, and turning on the sweat glands. It's a very real physical response to a completely phantom signal.
So really, you can boil it all down to this simple, powerful equation. A drop in estrogen leads to a surge in neurokinin B, and that triggers a hot flash. It is that direct.
Okay, so just understanding the problem, this clearly is a huge breakthrough. But what's even more exciting is that it points us directly to a whole new kind of solution. Not messing with the whole system, but just blocking the signal itself.
For so long, the go-to solution was hormone replacement therapy, right? Just put the estrogen back in. But now, what if you could just block the false alarm instead of trying to replace the missing calming signal? Well, that's exactly what this new approach does.
This side-by-side chart makes the difference crystal clear. On one side, you've got HRT, which replaces the estrogen. It's systemic. It works on the whole body. But on the other side, we have this new class of drug, an NK3 antagonist. Look at its target. It's not the whole body. It's super specific, right to the receptors in the hypothalamus. It blocks the false alarm right at the source. It's incredibly precise.
This quote just nails it. The whole point is to quiet down those haywire KNDy neurons. And this new approach does exactly that, but it does so without having to reintroduce the hormone that was lost. It's a really elegant solution that gets right to the root of that neurological misfire. So what's the big takeaway from all of this?
I mean, it's a massive shift in how we understand a really common experience.
Let's just quickly run through what we've learned. The big one. Hot flashes are a neurological event, not just a hormonal one. They're triggered by these overexcited KNDy neurons in the brain's hypothalamus. This hyperactivity sends a false overheat signal to the body's thermostat. And maybe most importantly, we now have new, non-hormonal ways to block that false signal right where it starts.
You know, this breakthrough is way bigger than just menopause. It's proof that we can actually pinpoint a specific brain circuit tied to aging and then design a really targeted fix for it. So it leaves you with this amazing question. Now that we can do this, what other mysteries of aging are we going to solve next?